Chapter 6 is about random variables. So random variables are something you'll encounter in almost all probability or statistics classes that you're going to take in the future. So a random variable is going to be a statistical variable that takes numerical values to describe outcomes. And they're going to describe all possible outcomes. And take a look at example number 1. So we're going to select a U.S. high school student at random, and we're going to define a variable. Our variable is going to be that X is going to be the number of languages spoken by a randomly selected student. This table that I gave you below is going to give what we call the probability distribution of X. So a probability distribution of a random variable, so I'm going to call it an RV here, is going to, the basic idea of a probability distribution is going to give all possible values. And the first thing I'm going to have you do is to show that the probability distribution here is legitimate. So in order for the probability distribution to be legitimate, you need two things. The first thing, which happens here, you'll notice that all values are going to be between 0 and 1. That's the first thing that you want. In this case, they are between 0 and 1, so it checks out. The second one is that all of the possible outcomes must add up to 1. And so you can check that on your own if you want. You can just toss them in your calculator and make sure that they do. You will find out that they actually do add up to 1. So we're good on that one. So that one checks out, that one checks out. So it is a legitimate probability distribution. So now for letter B, I'm going to ask you the probability that a randomly selected student speaks at least 3 languages. I feel like you probably have seen something like this before in our previous chapter. So what I'm going to do, though, is I'm going to show you a new type of notation to write this out. And actually, for all probability things, it's a good idea to write it this way, especially if you're on the AP test, so they can see what you're doing. So I'm going to write this as the probability that my random variable X, remember that's the number of languages, is greater than or equal to 3. So this is saying the probability that the number of languages spoken is greater than or equal to 3. And that's going to be written as the probability that X is 3 plus the probability that X is 4 plus the probability that X is 5. So we want them to speak 3 languages or 4 languages or 5 languages. And when you're doing an OR type probability, you're just going to add them all up. So then you're going to go ahead and just add these up. And in the end, you will get that it's about 0.075, which is about 7.5%. So our next vocab word is a discrete random variable. And actually, the number of languages in the previous example was an example of a discrete random variable. So a discrete random variable is going to take on a fixed set of values, and they're going to have gaps in between. And by gaps in between, I mean that there's going to be, it's not going to continue on. For example, we had 1, 2, 3, and 4 were our possibilities. So there's numbers like 1.5, 2.5 that were in between that we did not include. So that's an example of a discrete random variable. Usually discrete random variables, but not always, they're usually going to be either integers or whole numbers. So I'm just going to say they're often going to be whole numbers. Okay, here's the next important thing. This is called the expected value of a discrete random variable. So an expected value is a fancy way to say the mean. This formula will be located on your AP formula sheet. It's going to be written as E of X, expected value of X, that's what that stands for, is equal to mu of X. This is going to be the mean. Then they're going to give you the this formula right here. the sum of xi times pi. So this is on the AP formula sheet. Keep that in mind. You will see it again. Okay, so for example number 2, we are going to, a lot of the, you'll find a lot of the expected value problems do have to do with gambling, because that is actually where they use expected value a lot there to calculate the amount that they pay out. So in this one, it's talking about a roulette wheel. There are 38 slots on it. The players can make what's called a corner bet, and on the table they have squares listed out on the table that you can put your bet on, and you put it on the intersection of 4 squares. So if you get any of those 4 numbers, you get your dollar back plus you get 8 more, which means that your gain is $8. So you actually paid $1, but you got that dollar back and you also got $8 more back. So we say that our gain in this case was $8. So if you look below, out of the 38 slots, the 4 of them were the ones that you wanted. You got back your dollar, you got back 8, so your overall gain was $8. Now, the other case is if there's 34 numbers that you could have gotten, none of which were the ones that you bet on. In that case, you would lose $1. So that's where this probability distribution comes from. And the question that I asked you is, what is the player's expected gain? So there's a few ways to do this. If you want, you're welcome to use the formula above. If you do that, your value is always going to be your x, your probability is always going to be your p. And in this case, I'm going to call this one x1 and this one x2. This one is going to be your p1 and your p2. So you can do the formula and plug things in as long as you keep the 1s and the 2s together. They correspond to each other. You don't have to use the formula though. Most people they do it so much that they don't even bother with the formula. So all you're going to do for your expected gain is you are going to rewrite it. You're going to multiply together -1 times 34 over 38 plus 8 times 4 over 38. That's all you need to do for this. You end up in the end getting -2 over 38, which gives you -0.5. And in this case, remember, we're actually thinking about dollars, so I'm going to say -0.5 or 5 cents. So you will sometimes get expected values that are negative. In fact, if you're gambling, you can almost be guaranteed to get a negative expected value because you are always expected to lose. So what this means, I didn't write to interpret what that means, but I'm gonna do it for you because you are gonna have to be able to understand it. What this means is if the player makes many bets, so for many corner bets, the player can be expected to lose 5 cents per bet. And that's per bet, not overall, but that's for every bet this person makes. And it is a loss because it's negative. For the next example, we are going to use the previous example that we had with the number of languages. And for this one, we are going to compute the mean of x, our variable, which is the number of languages. And in case you weren't sure about this, the mean and the expected value in this case are the same thing. So if I ask you to find a mean of a random variable, just know that that means you're finding the expected value. Okay, so we are going to do similar thing as to what we did in the previous one. You can either write it as mu of x or e of x. And all we're going to do is we're going to take each of the languages, multiply it by its probability, and we end up getting 1.457. So I asked you to interpret this also, and what I mean, and on your test, I'm also going to ask you to interpret it. And so what that means is that if we were to select many high school students, and the key thing on this is that we would be selecting many of them, then the average number of languages that they speak would be 1.457. And one thing I want to mention that's important is do not round the expected value. Even though it doesn't really make sense to speak 1.5 languages, it's still going to be not rounded. So the reason is because it's going to be an average. And averages, we don't round to the nearest language. So just be careful about that. Okay, so next thing we're going to do is we're going to talk about finding the standard deviation of a discrete random variable. This is another formula that you'll see on your formula sheet. And if you find, for example, number 4, that doing the formula is way too long for you, actually, if you look in your book, there's a technology corner on page 354, and it will show you how to find both the mean and the standard deviation of a random variable. So you're welcome to look through that and try it out and do it that way. Most likely you're not actually going to have to do this on the AP test, but I am going to make sure that you know how to do it for my test. I'll probably give you less than 5 as I have in this example, just to make it easier on you. So we're going to start out, and we're going to first find the variance. And just a little recap, the variance is the standard deviation squared. You'll notice I use a sigma for this one, by the way, a lowercase sigma. So what I'm going to do is I'm going to take my mean that I found in the previous example, which was 1.457, and that's what this is right here. And then I'm going to find each language's distance from that. Each of these values is going to be my x. So for example, this is x1. And each of these values down here is going to be my probability. For example, this is p1. So you can use those to help me out. What we're going to do is we're going to do for each of these, we're going to do the x value, the language, minus the mean. We're going to square it so we can make sure it becomes positive, and then we multiply it by its probability. Then you're going to do that for all 5 of these. So it does end up being a little bit long. You're welcome to go through the steps to do it on your calculator. If you, I will tell you though, on the test, I'm probably going to give you one that has only 3, just so you're not going to be spending too much time on it. Okay, so when we do this, if you want, you're welcome to work this out on your calculator on your own. You can put it all in. You'll find that your variance is going to be 0.45. All you need to do from there is you're going to find your standard deviation by taking the square root of your variance, and you do end up getting 0.671. So the opposite of a discrete random variable is what we call a continuous random variable. And a continuous random variable is going to take on all values in an interval of numbers. And by all values, I mean all decimal points and fractions. You'll see this for something like heights or something like that. For example, if I were to measure your height in inches and be extremely exact, you can have a height of like 68.2 inches or something like that. That is completely okay. Or you can have a height of like 61.857. That's okay too. So it's going to take on all sorts of values in there. It is a continuous thing. And the next example is going to look really similar to something that you've seen before. So you'll notice that they tell you that the weights of 3-year-old females follow a normal distribution. So this means that you're going to be using the normal model. So we have a mean of 30.7 and a standard deviation of 3.6. We are going to call the weight of one 3-year-old female, this is the random variable, we're going to call it x. So you don't have to rewrite this, but it's always important to define whatever your variable is. Let's say 3-year-old female. So if they do not give you something like x, make sure that you define a variable if you're going to use anything in there. And we want to know what is the probability that a randomly selected 3-year-old female weighs at least 30 pounds. So I'm going to start off and I'm going to draw the normal model for this. And I'll just draw a quick sketch. In the middle is going to be 30.7. And I know 30 is going to be below there. What you can automatically tell is you can automatically realize that the answer should be more than 0.5 or more than 50%. So the next thing I want you to start getting in the habit of doing is when you use the normal model, write it out as a probability. So in this case, we know that we're looking for the probability of the weight being at least 30. So my weight I called x. I'm going to write this as the probability that x is at least 30, x is greater than or equal to 30. So then you can use your normal model from there. We are going to use Normalcdf on your calculator. And we are going to go 30. You can do any big number. I'm going to just do like 1,000 or something. And then you do 30.7 and 3.6. The other thing I want you to start getting in the habit of is when you write out the normal CDF, label it. So the 30.7 I'm going to label as my mean, mu. The 3.6 is my standard deviation, sigma. And 30 is my lower. And 1,000 is my upper. And you'll see those same things on your calculator. So it's a good idea just to label that. That way the person grading it knows what these numbers are actually going to mean. So what I'm going to do now is just, you can use your calculator for it. You end up getting 0.577.